Okay. Welcome to Click Academic. This series of videos will be on a topic or course titled Set and Number System. But our today's topic or lesson will be on set. As you can see that the course has two segments, set and number system. As I said before, that our today's lesson will be on set. First, we have to look on what it set itself. A set is a collection of a well-defined object. It's a collection of a well-defined object. This is symbolically is being denoted by this, which is curly bracket. It's not an ordinary bracket like this. It is a word, a curly bracket, ably represented or denoted. Once we see something like this, we know we are talking about set in mathematics. Then example of a set in terms of what we're talking about, well-defined object. Now let's take about example of these two examples. Set of a numbers. We have 1, 2. Any word, the difference between element and another element should be a word, comma. If you are not using this, meaning it will not make any sense. But we have 1, 2, 3, meaning 1 is an element, 2 is an element also, so on, so on. Then set of an odd alphabet. It's not necessary to have only number. You may have a set of an alphabet, which is what? Just to show that their word object, ably represented by the object. So this is what? 1, as you can see, here we are what? Separating it by comma, and also here we are separating, and all are inside what? The curly bracket, which is the set. So this is an example of what? A set in a well-defined manner. So what about in the one that is not well-defined object? Okay, let's take example. Let's say, okay, we have 1A, 2, 3, C, D, maybe let's say 8. This set is not a well-defined set. Why? Because it has a mixed object that are not well-defined. Because we have number, which is 2, 2, 8. And we have what? A, C, D. Is not a well-defined object. So this is what you call a set. Set is a collection of a well-defined object. So, and denoted by this. So anywhere you see this, it's represent what? Set. Then we'll talk about what? Set. Then in a set, maybe there are some things that we need to know, which we call them set notation. Now, when we look about this set notation, we have the first symbol, as you can see, ably represented like the letter. And sometimes you do write it like this, which is what? This represents element of a set. Let's take example. Let's say you have, okay, A of what? Capital A. Meaning this letter A is an element of what? Set A. Then if I want to show the world that I, Omar, belongs to my father's house. So this is how I will arrange it. Maybe here will be Omar, then maybe here will be my father. Then this relation is up that this belongs to this. So meaning this element is an element of what? A. Then when we talk about not element of the set, okay, I can say A is not an element of capital letter A. This is the symbol. If we see this, we know that you are talking about that this A, small letter A, is an element of capital letter A. But here it's ably presented saying that A, small letter A, is what? Not an element of capital letter A. Then this is about this. Then let's go to the next one. We have what you call a universal set. A universal set. Let's take example in a school. School in a situation whereby as a matter you can consider it as a universal set. Classroom, we call it what? A subset. You understand? Or set before subset. So here, universal set, maybe as this example which I laid, okay, let's say we have, okay, let's say we have 1, 2, 3, 4, 5. Here will be what? This is a universal set. Maybe I have a set like this. 1, 2, 3. Maybe I have B. 1, 4, 5. So you see, these are sets, but this is the universal set. I hope you understand. So then let's talk about the next symbol, which is a union of a set. Union of the set, let's take these two examples. Is what? Is the collection of a what? Two sets or more in a one place, in a well-defined manner. What do we call by well-defined manner? Maybe, let's say, okay, this symbol, which is A union of B, is heavily represented by this. This is A, this is B. And if you look at this, we have 1, we have 1. You put 1, comma. Since it's 1, then if I put this 1 also, it's like I'm repeating. So it doesn't make any sense. That's why we say it's what? In a well-defined manner. So here is what? We put only 1. We don't care whether it appeared twice. We only consider 1. Then what next after 1 is 2. Do we have 2 here? No. Then what next? 3. Do we have 3 here? No. Even though we have, we ignore it. We consider it as 1. Then what next here? 4. What next? 5. Therefore, this is a union of these sets. Then we talk about interset. Intersection of a set is like a relation whereby we are having an element that found in A and also exists in B. So, and this is heavily represented like this. Now, if you look at this, we have 1, 2, 3 as an element of set A. We have what? 1, 4, 5 as an element of set B, right? So, now which element does it appear here in set A and also appear in set B? What element? You see that it is what? 1. So, meaning what? 1 is then what? Intersection of what? Element or A and B. So therefore, A intersection B is what? Is 1 as an element. So this is about what? Intersection. Then we talk about empty set, or we call it null. Anyone you use it is preparable and heavily represented by these symbols. Whether we make it like this or like this, we know that it's an empty set. But when you go deep beyond this level, you learn to know that it is not an empty set where it exists. There is something that exists, but as our level today, we are going to consider it as an empty set. Then after that, we have a symbol like this. You see, this A is represented as in set, but this is the symbol of what you call complement. A complement of a set. This carried like this, or small c as in power. It represented a complement of set A. So let's take example of this set A. Then what is the complement of this set? Okay, we now say okay, A complement is equal to, then the way we are going to getting our complement is any element that are in the universal set but not in what? In set A is the element of what? Is a complement. So this is what you mean. So now I just make a small comparison. 1 also appear here, so 1 is not there. 2, which is also there. 3, which is there. Then 4 is not here. Therefore, 4 is what? Is one of the element that is complement. What about 5? Do we have 5 here in set A? No, but it is there in universal set. So therefore, it is what? It is in what? Complement. So this set is what? Is a complement of set A. These are the elements that are in the universal set but not in set A. This is what we mean by complement of a set. Then let's talk about a subset. When we say subset, is like we are trying to make a relation between two sets. Let's say I have this set A and let's say a universal set like this. If you consider this 1, 2, 3, these are the elements of set A, but are all in what? In universal set. So meaning this A is a subset of what? Of universal set. Because whatever A contains, universal set what? Have more. It contains it and have more. So therefore A contained in B, or in universal set, I mean. I hope it's going around. So therefore we can make it like this, which is what? A is a subset of what? Of universal sets. We are saying that all the elements of A are in what? universal set. This is the end of today's lesson. In our next lesson, we'll see how to use them in an example, and we'll see how the example will look like. Thank you very much.